Artificial intelligence like ChatGPT and other approaches, can that be used to deduce whether or not a data source is real or potentially fraudulent?
I don't know the answer to that question. I have been known as a bit of a machine learning AI skeptic, and I
Mhm.
think some of the things coming out of ChatGPT are truly astounding. But they're doing different things than we're doing than you'd be asking it to do to analyze a data source. So um, backing up for a second, when we've been using AI or ML to do prediction, particularly in the medical sphere, it has not outperformed a standard statistical analysis. Um, and you ask, why is that? Well, that's because largely the data sets that we're using are not really big data sets. Big data sets don't have 10 features, 20 features, 50 features. They have 1,000 features, 10,000 features. That's when the real power of AI can come in. So when you have a relatively small number of features, our standard statistics work pretty well. Now, where AI has been very successful and has outperformed other things has been in image recognition, because you're just dealing with pixels, and it's a limited number of ways that variables we can look at, and it's been very successful in saying this is a cat, or whatnot. And now you can make it do with large language things. All right, write me a sonnet about such and such, and it can imitate that. It's okay. And it's not found as much success as we would have hoped were, but seen it's a lot of application has been in omic analysis, in transcriptomics, genomics, metabolomics, et cetera, and melding that with clinical information to make better predictions about who is at greater risk for progression of disease. And that's because, to some extent, we still have to use shortcuts. So when you do these analyses, and if you're going to look for every possible correlation between everything that's there, if you run all of those correlations, it can take weeks or months to have a runtime. So what they currently do is they take shortcuts. They say, well, we know this part of the genome is part we should be paying attention to, so we'll pay attention to this part of the genome, and we'll ignore the rest. But we know that the stuff between the genes is very important from a regulatory standpoint. And we also know that with the binding of materials to the DNA, epigenomics, that it changes the impact of what the DNA is telling the cells to do. We haven't even scratched that surface. So the amount of complexity is much, much greater than we're actually scratching the surface of. And we're just not there yet. And so that part of the limitation is runtime, or you could say part of the limitation is hardware. Graphical processing units were much better than CPUs, but they're not where we need to be, even if you array them in multiple nodes. We're going to need some breakthroughs in technology, and whether that turns out to be quantum computing or something else, I don't know. But we're going to have to upgrade our hardware in order to be able to actually explore the true power of machine learning and artificial intelligence. And that may happen in the near future. I don't know, but I'm not expecting it.